Kind of weird, huh? Ready to do it? Let's do it. Okay, we need to make an isosceles triangle out of this. Now the way I like to do this is to come up with the slope between the 2 points, right? So once I get the slope between the 2 points, then I can plug in the value. And that value is going to cross the y-axis at some point, finding b, right? So, if I find, no, sorry about that. I'm going to take these 2 points, right? And then what I'm going to do is find the midpoint. That's what I'm going to do. Find the perpendicular bisector, right? And then wherever that perpendicular bisector lands on the y-intercept, then I know that these two angles, or these two sides are congruent, forming what we call a isosceles triangle. No matter where these two are, right? Where these 2 points are. They can be over here, same thing. The idea is a perpendicular bisector wherever they end up, so that I have an isosceles triangle. So, instead of graphing it and all that stuff, I'm just going to do what I just said I'm going to do. I'm going to find the midpoint, and then I'm going to find the slope, and I'm going to find the perpendicular bisector. And then I'm going to plug it in to find the y-intercept. It's that simple. So the first thing is how to find the midpoint. Oh, I need to add the x's, right? So a student of mine said, hey, stack it and divide it, okay? So in other words, he said, hey, if I got 12 and negative 4, then I have negative 5, negative 16, I can stack those up, add them. So I have 7, and so when I add these, I have 7, and I have negative 20, and then divide by 2, right? Divide by 2, divide by 2, and I get 3.5 and negative 10. And that's what we call the midpoint. So right there, I know the midpoint. Okay? So that would be this point right here, or this point right here, wherever it is on the in the graph. Okay? And then what I'm going to do is try to find the slope, okay? Whatever the slope might be. Okay? So, flip it and smack it. That's how we found the slope. Right? So I'm going to flip it, meaning negative 4 over 12, and negative 16 over negative 5. Now, a lot of times, remember, your formulas for midpoint is actually x1 plus x2 divided by 2, and y1 and y2 divided by 2. Okay, and that's your midpoint formula. For this, you have the slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Which, if you watched the last video, you would know that we flip it, smack it, rub it down for distance. But for slope, we just flip it and smack it. So when I flip these so that I have x and y, right, flip it, and then I smack it, boom, boom. That is my slope. That's delta y over delta x. Y over x. Okay? So, since that equals my slope, then I do the math. So this is adding, so that would be 12 over 17. And that is my slope, right? So, my parallel slope, or what I like to go slope parallel, would be the same slope, 12, 17. But my perpendicular slope, right, M perpendicular, is actually the opposite inverse. So it's negative 17/12. Right? So in other words, these 2 points have a positive slope. So they actually, these 2 points go like this somewhere. Looks like in the negative quadrant, which would be 3rd quadrant, right? And in the positive negative quadrant, which would be the 4th quadrant, right? So somewhere this point is in the 3rd, this point is in the 4th, and we're finding this midpoint somewhere, wherever it is. It might be on this side, that means it's going to be down here. If it's on this side, then it means it's going to be up here, wherever it crosses the y-axis. Okay? Alright, so I know my slope. Now I just got to figure out the y-intercept. So to find a y-intercept, I'm going to choose one of these points. I like this point because it has one positive, one negative. You know, the least amount of positive or negatives, the better. Alright, so I throw that in. So I say y equals mx plus b, where I'm going to use this perpendicular slope. Okay? Oh, whoa, I can't use this point. I have to use what's called the midpoint, duh. So I have to use this point. Because I want it to be a perpendicular bisector, right? So I'm bisecting that at the midpoint, wherever that midpoint might be. So I'm going to use this point in here. So my y is negative 10. My m is negative 17 over 12. My x is 3.5. I'm going to put that back into a fraction. So that's going to be 7 over 2, right? And then plus b. And, oh, that's a really nasty number. So this is going to really be gross. Nothing cancels. The 7 doesn't cancel out with the 12. The 2 doesn't cancel out with the 17. This is, hey, welcome to pre-cal. Huh? What?
Question, right?
What question are we on? That's a great question. What question is this? 30.
Oh, sick.
Sorry about that.
Sick.
Alright, so I gotta actually take 7 times 17, which is, or negative 17, which is negative 70 plus 49. So that would be 119, correct? All over 24, right? And I'm gonna actually add that to both sides, okay? Now when I add that to this side, I'm going to ask myself, get that? It was funny. Okay, I'm going to say self. Still not funny enough? Okay. Thank you! Jeez, trying to get a laugh in here. It's so difficult. Alright, so when I'm going to say, hey, how many times does 24 go into 100? And it goes in 4 times, right? With what left over? Right? 4, right? So 4 added on to 119, 4 added on to 19 is going to give me 23. So that means there's 23 left. Oh, goodness gracious. We were so close to going in nicely. And so we did it. So we go into there 4 times with 23 left over the 24, right? And we're going to add that to this piece, to this negative 10. So when I add 4 to negative 10, I get 6, right? But when I add 23 24ths to negative 6, then I get what? Negative 5 and 1 24th, right? Okay? So that is my B. Okay? So that's where it crosses. Alright? So, when you're asked, hey, do you know a point on the y-intercept that would create a, what's it called? An isosceles triangle, right? Yes, I do. That point would be negative 5 and 1/24. You see, I could go over 12 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and down 4. 1, 2, 3, 4. Boom. Okay? And then I go -5 and down 16. Okay? So that would be about there, right? When I make this point, somewhere would be the midpoint, right? Which would be at 3.5 and -10. So right about here. Does that make sense? And then I'm going to create this slope, and that slope is going to cross at 5 and 1/24. It's -1, 2, 3, 4, 5 and 1/24, right? So right there. And that point is going to create what we call an isosceles triangle. And that's how difficult that problem is. But what is that point? That would be 0 in the x direction and -5 and 1/24 in the y direction. And that is the point that would create a beautiful isosceles triangle out of this line from these 2 points. Yeah? Fun stuff. Questions? So I'm sure that went over like a sack of potatoes on a hobo's back. And
Looks
just
like a
sat there.
mess.
Huh?
Looks like a mess.
It's a big old mess.
Is it? I couldn't tell.
No, not really. Remember, the key, we're taking these 2 points. This point is in group 4, right here. So let's call that the red point. Okay? And let's call this the purple point. Okay? Now the midpoint between these 2 points is going to be about right there, really. When we take that midpoint and we take the perpendicular, so we figure out from these 2 points the slope. Okay, found the slope. Then we find its perpendicular slope. And we have it go through that midpoint. Right? So this was the midpoint. This is the slope. It's the perpendicular slope that goes through that midpoint, and it crosses at -1, 2, 3, 4, 5, and 1/24, right? And when we do that, we create this beautiful isosceles triangle, right? It's isosceles because this is what we call a perpendicular bisector. That means these 2 sides have to be congruent, right? And because those 2 sides are congruent, that means that the 2 angles created here are going to be congruent. And because those 2 angles are congruent, these sides have to be congruent. It's all your lovely geometry blended in with your algebra. Okay? So, knowing how to get from your that into your y equals mx plus b, trying to find your b, that b is this point right here. Woohoo! Yay, team. You're welcome.
Good job, Dan. Proud of you.
Hey, high five.
I was here for all of it.
Right?